Okay, hello, welcome back. And going to talk about measuring today, and as the title says, it's oscilloscope versus front door diagnostics. Yeah. Now, what I'm holding up here is something that the old school know about. This is your vernier gauge, measures 1/10 of a millimeter. Yeah, 1/10 of a millimeter. You can, as you know, you can measure 15,000th of an inch or 0.15 of a millimeter, for instance, and this is engineering stuff. Okay, it can get batshit crazy. The tolerances and newer stuff a little bit more tight than other or older engineering. However, what I find is that people don't quite grasp the concept of tolerances. Yeah, I'm not going to talk about it now. I just had a comprehension that people who were watching my engine rebuild video, they're the type of people who would prefer to just chuck a set of shells on a worn crank and have done with it, whereas there's a lot more to measurement. The better you get, the more accurate you can measure something, the more of a tolerance you can work to, and the better something will run. Okay, but I digress. Okay, same with these oscilloscopes and multimeters. People are only interested in getting results rather than understanding the concepts behind it. But what I'm going to do is try to endeavour here to show you a little bit about the oscilloscope, and just so you get an understanding of what's actually involved in it, because today's modern motor vehicles, unfortunately or fortunately, they are computer controlled. Computers work very, very fast. They work faster than your multimeter can, and although the multimeter can be used for some diagnostics, there's other times when you need an oscilloscope. So even if you don't own one, you're not going to buy one, you DIY, then just understand that workshops and mechanics charge money because the equipment's really expensive. Yeah, but they use this sort of equipment for diagnosis to get things right. Right, I know there are complete tossers out there. However, I'm not going to get into this. Generally, mechanics are now trained on this. So what I want to say now is just relax your mind and try to comprehend 1,000th of a second interval. Yeah, can you comprehend that? 1,000th of a second. You can't see it, but you can measure it. Okay, and that's what oscilloscopes are for. If I said to you 200 millionth of a second, can you picture that? That would be a bit more sort of nebulous, where you're looking at like the cosmos and oh my god, how big that is. And it is, if you split up a second into a millionth of a second, or 1 million divisions in a second, yeah, that's actually massive. Yeah, and the ECUs are working at very high speed rates, sending signals and receiving signals from components, so they can adjust them and they can monitor to make things run right. And yeah, we can't get away from this. Even with electric vehicles, there will be systems that are running very, very fast. Yeah, so we've got to try and have a look and see what these things are doing, so we can see if it's dropping out somewhere or if we have a loose connection, and then we can work on the premises that maybe there's an ECU that's fucked. For instance, if you're looking at a CAN signal and it's not quite right, or you're looking at an airflow meter and the signal's not there because it's lost its earth. You see, there's quite a lot to it. Once you start to know that you're getting a picture representation in front of you, it's so easy. It's unbelievably easy. Yeah. So I'm going to show you some things about front door first of all, and then the back door, which is the oscilloscope. All right, just basic for people who are trying to grasp this. Yeah, the Land Rover I had in a couple of weeks ago with the Maf sensor and the IAT issues, that was a loose connector. I put a new Maf sensor in, integral one, and it clicked into place, and that was solid. And I took the thing for a road test. I monitored it with my diagnostic equipment, my Ethos tech, and it came out nice. That was okay. Sent the vehicle away, it never came back. That's all I want to see, is it's fixed, done, gone. Yeah, I get paid for my time and I'm happy. Yeah, using the oscilloscope obviously is a good way of looking right deep into what's going on. Yeah, if you could do that to your wife, plug an oscilloscope into her head and see what frequency of the thoughts are going on, you'd be surprised actually. Yeah, anyway, I also had a Peugeot in with an alternator fault, which actually the front door diagnostics, okay, didn't need to do. I used the back door, which back door is into the ECU, reading what the ECU is doing. Yeah, front door diagnostics is actually seeing where the sensor is and seeing what the sensor's doing and along the wires. Yeah, but the back door, plugging into the ECU and see what the ECU is doing. There are times when you need to check your ECU to see what it's doing, especially in the case of this Peugeot that I had. It was what they call it, it wasn't CAN controlled voltage, but it was some sort of ECU controlled voltage, okay, which meant that it was sending a signal to the alternator to tell it to open up more or shut down more. Yeah, and I sussed this. Okay, so what I've got here is, actually I'll just go back one. This is my Ethos Tech. Okay, now what I can do is save data. Now this is in XML and BMP form. BMP is a screenshot. I'll do that by pressing this button as a way to show you certain stuff. So I've got saved data here. Okay, now what you'll find with quite a lot of readers is that you get, I don't know, let's say you get fault codes, you get a few things that you can activate, and there isn't much more to them. Yeah, so this one had this had loads of issues. Yeah, oxygen sensor, and the ECU is this is just basically garbage. There's a lot of stuff that that I cleared and never came back. One thing I was interested in is the CAN data stream from the BSI. This actually came out as a persistent fault, but this is not what I want to talk about. Basically, you get a lot of stuff in readers, and it's even worse when you get something off eBay for like £10, because that will only read an EOBD side of the vehicle. Okay. What I like, now this is a screenshot again, is this sort of information presented to me. This is voltage over time, yeah, and it's the same as the oscilloscope. So what I have here is Peugeot 2013 Expert, and I had issues with the alternator. The battery voltage was at about 11. This here, which is the alternator progress, was at 100%. It was 100%. The ECU was telling it to open it at 100% so it could then charge up, which it wasn't doing. Now I changed the alternator out, and you can see here straight away 14.8, and this is at 29%. Yeah, it actually went up to 51% when I revved it. As you can see here, okay, in graph form, the revs went up and then dropped back down. At this point it's 783 RPM, yeah, but the voltage has stayed consistent. Yeah, and this is progressively opening and shutting to make sure that the voltage is stabilized in the vehicle, okay, and the amperage is correct. This one down here, supply voltage, I mean, if you didn't know that a supply voltage for 5 volt sensors, okay, this is actually in millivolts, not volts. Yeah, so that's only like 5 volts. Yeah, so you can see that goes up quite a lot, but that is not moving much if you see the figures underneath here. Okay, so this is what I like to do when I'm monitoring a vehicle, is see it in graph form, so I can make a decision very, very quickly of what's going on without having to keep taking measurements from one place or another. Okay, I know there's always another way around things, but this is what I actually like. Yeah, now again, I want to talk a little bit more about voltage over time. What I have here is very simple oscilloscope reading. Okay, now this will be 500 milliseconds. This is actually recorded. Yeah, it's not live, this is recorded. 500 milliseconds. You can see down here, that's half a second. So between this point here and this point here, that's half a second of spinning a wheel and getting a voltage signal out of the vehicle. Okay, now I can actually move this, span the wheel a bit quicker, so there's actually more peaks and troughs. within that half a second. Yeah, there's an awful lot going on because this is only being pushed around at a meter per second. Yeah, this is ABS sensor voltage. Okay, so if I can just, yeah, okay, so the voltage dropped a little bit there and then it came back, and what I'm looking for obviously with this is to see as well what voltage it's putting out, what type of signal it's putting out. This is actually perfectly pure without any dropouts in it. This is the thing about oscilloscopes, is looking representation of what's going on very quickly, so you can get the job done as quick as you can. So what I'd like to do, I'll show you something else. This is all stored data in this Vantage Ultra. Yeah, this is all work that I've done. This was the 5th of the 2nd, this is the 4th of the 2nd. Let's see what I had here. I get a lot of work. I use this quite specifically on the diagnosing stuff, which is going to take a lot of time. So I'm cutting corners here by plugging in and looking at stuff very quickly. And because I get a window, for instance, I've got 1 second and I can expand that second right out to see what's happening in that 1 second, then I can catch things. And this is what it's all about. So this is going to take ages to load up, basically because this is just slow. The job of this is to have a high sampling rate and read sensors and information that's being put out to a sensor or something, like a step motor for instance, or to see what the ECU is receiving back in signal form. Okay, now what I'll say, the difference between this one and this instrument here, this one you have to plug into the ECU. The ECU might put default values on something and you don't get the full truth, whereas something like this, okay, this is a representation of what exactly is going on. Now what this is the piezo, and if I just put these in, this, okay, was the control wire to the alternator, and basically it was sending a signal, as you can see here. It was sending a signal to open the alternator out to 100%, yeah. But the voltage was at, you can see by this one, number 1 here, it was at only 11 volts. So the system wasn't doing actually too well at all. Now this is a data signal. I think it was multiplex, I'm not sure, but by looking at this I knew straight away that it was sending a signal out, even though the voltage was low. I knew that because the whole system voltage was low. Yeah, so it wasn't putting out enough. Okay, so it was basically moving like that. Yeah, you can see that, and this is what I expected to see. Yeah, now you couldn't do this with a voltmeter. All you'd see is like you had 12 volts there, and you wouldn't be able to see anything more than that. Okay, so let's do another one. This was on the same day, the 25th of the 1st. Let's see what this was. I think this was the Land Rover Defender airflow meter, and this is, again, it's going to take time. These always do. I love this bit of equipment. This bit of equipment is something, even if I wasn't professional, it would save me so much of a headache. Is to learn something about this and get on and do the work very quickly, because there's nothing worse than having to ask people their opinions about things and just getting internet and forum garbage. Yeah. If you're the type of person who likes being on forums, then fine. If you're not, like myself, I find that a lot of people can talk just utter crap. Yeah. I'm hoping you can see the screen okay. I'll just bring this in, zoom this in a bit. So basically what I have here is 2 channels, and I had one plugged into the earth, which was reading at, let me just show you if I can drop that in there. Okay, we'll look at number 2 here. That was a 0.0, yeah, 0.08 of a volt, which is a good ground. Okay, now this was the signal of the Maf sensor, okay, which looks perfectly uniform, and you can see here it was going up on for 5 volts. Okay, and at the time, as I said in one of the videos, that I wasn't actually looking for the voltage reading, even though it's here. Okay, I was looking for the integrity of the signal and see if it would drop out at any point. Okay, now all of that looks actually pretty damn good, and to me, instantly, that I knew, even by looking at these 2 lines, that I had a good earth and I had a decent signal on the Maf sensor, which was good enough for me to say, yeah, okay, that is working. This one here was after I put a new Maf sensor in, and I'd already checked the wires, so that's all good. Yeah. Now, the advantage of using snap-on gear, okay, is that all these I can put onto ShopStream, and I can actually open any of these files out and read them with much more accuracy. 3rd of 2nd 2016, actually that's garbage, you don't want to see that. Some of these are files that came in with an update on this, and it wasn't worth updating. It does take a while to view the files on this screen here, but if I put it onto a PC, which I don't have a good one in the house, then I can read the files pretty good. Okay, so yeah, this is an excellent piece of equipment. Absolutely excellent piece of equipment. This has saved me so much time and a lot of grief. Even though the cost is prohibitive compared to a multimeter, it is worth its while. So the last thing, just basically what I want to show you is the how the oscilloscope actually works for some of you guys, and just to get a picture in your mind of the time base that's involved in it. A lot to it. Yeah, it's an expensive bit of equipment, and even though you might not be able to afford one, then even just an understanding and an appreciation of what technicians have to do to justify the work that they do, because this stuff is not going away. Any technician who works on electrics that's not using an oscilloscope now is a retard, to be honest with you. He's a guess it and do it, or he's using a multimeter with a lot of knowledge. Yeah, and this will only be in specific areas. Now, I work with guys who work on daft trucks all the time. They know the voltage values of the vehicles and they can use a multimeter. However, when they have to approach another vehicle, they don't. They literally don't. What they do is they run away and leave it to guys like me, who then have to think on their feet. All right, multitude of vehicles, multitude of different ways that they work. There are common foundations to it all, but with something like the guided help that's on these oscilloscopes, it means that you can actually start to home in and get a damn good idea of what's going on. Yeah. Now, for anybody who has got an oscilloscope that's not actually sure they got one in the workshop, there is a book, Graham Stokes. He shows the waveforms that you should be producing by certain components, and this is a book that's interesting to look at, and I would advise you, if you're only just starting out on it, go and have a look. Okay, it's an excellent book. You also have the Picoscope website, which if you join the forum, okay, you don't have to have a Picoscope. You can use the information that's on that website, and it will help you out to start off. Picoscope are brilliant. They're actually better than the snap-on kit, and the price is comparative, so you generally get what you pay for. Anyway, this is enough from me. Thank you very much for watching, and I will see you in another video soon. Okay guys, see you later. Okay, then I want to show you the oscilloscope, which is for front door diagnostics, and basically this is what you plug into sensors so you can see what the voltages are doing. Okay, so I've got a scope multimeter. I like the lab scope, 2-channel lab scope, for instance. Okay, this will only give me 2 channels, one here, one here. Okay, this isn't doing anything at all. So if I zoom in a little bit, okay, I'll show you what this interface is all about. Okay, this is touch screen. Yeah, you have your trace here. Okay, this is your voltage representation, green for the green channel, yeah, and yellow for the yellow channel, and you can actually move these about. Yeah, you can see that on this side. You can move these about to get them on the screen better. Okay, now you have your voltage base, okay, like say 5 volts. Okay, I could go down to 200 millivolts if I want to, or up to 200 volts. Yeah, okay. What was that on? 5 volts or something, wasn't it? Yeah, so you're at 5 volts. Okay, now you have trigger settings. These are triggers which stabilizes a signal. Okay, I can set a trigger for the green. You can only do it on one. The green trigger down here, for instance. What this will do is to stabilize any signal, so it isn't just rushing past. It will actually stay on the screen. Yeah, and we have refresh buttons here. Okay, and then we have our voltage readings, which are live, minimum, maximum. Okay, now you also have cursors at the top here. Okay, the cursors, where you read the cursors from, is where you will get these voltage readings. Okay, there is ghost voltage there, you can see that. Yeah, we've talked about that before, ghost voltage, when you haven't got a solid ground, for instance. All right, so what down here we have is the time base, which is along the bottom. All right, at the moment that's 1 millisecond, which is 1,000th of a second. So between here and here is 1,000th of a second. Yeah, and you can see the increments here. Yeah, so that's 100 millionth of a second. This one is 100 millionth of a second. Yeah, so you can see what sort of sampling rate this has to do, and to keep up with the information coming on the screen, it's actually pretty good. This will read certain signals, yeah, like CAN lines, for instance, CAN signals, fairly important. Okay, now 500 milliseconds. As you can see here, 500 milliseconds is half a second. Yeah, 1 second here. Okay, 100 milliseconds. That's 1/10 of a second. Yeah, so you can see what sort of power this has. Yeah. Now I can't. This is not live. I can't show you anything. Nothing's plugged into this oscilloscope. I can switch the channels off if I like. Turn both of them off. I've got nothing on the screen. Turn the green one on, and boom, I can read that. I like, if I'm using just one channel, is to use the yellow one, because it is actually more visible in a workshop. Yeah. Up here I can save the data, and then I can analyze it later, or show my boss, for instance, what I'd found if I get any problems. Okay, now this is a very, very powerful piece of equipment. Okay, I'll go back again. Graphing multimeter, digital multimeter. Well, digital multimeter basically is just figures. Yeah, let's just do volts DC. Okay, basically that's what you'll get. That'll be ghost voltage. Okay, the graphing meter, on the other hand, is different. There is a difference, because what that will be is like the lab scope, which is graphed. Yeah, so again, you have, like, say 20 volts down here, and 1 second time base, so that's 1 second between there. Okay, and you also have peak filters, and also depending on what type of instrument you've got plugged in, yeah, this is what you will set it to. So you can hang on, I'll just take this down. Test leads, duty cycle, volts. You can also do vacuum. You can read vacuum, you can read pressure with this, if you have the right equipment. Yeah, okay, and then there's amperage, low amperage or high amp. Yeah, ohms, blah blah blah, even temperature. Yeah, if you need to. The equipment for this is very, very expensive. Anyway, I'm going to come out of that. I don't want to reset that at all. So you just get an inkling of what's happening here. Alright, so you also have guided components tests for certain vehicles. Now this is well out of date. Okay, and up here you have a how to do on things. Okay, so if I go all others generic, for instance, this will then have screens to tell me, or it'll be set for certain things like fuel injection, high pressure common rail injectors, camshaft position, position sensors, metering valves, fuel rail pressure control valve, fuel rail pressure sensors, injectors, for instance, piezo or solenoid type. Yeah. and then the signature test, which I've shown in a video before. Yeah, and it will actually, you have guides here down the bottom here that will show you what sort of waveform you'd expect. This isn't very accurate, but it's somewhere close. Yeah. So anyway, I'll go back home again. That's that kit in a nutshell.